All right. Let's see. I think that's everybody. Yeah. Okay. So welcome, gentlemen. I hope you all had a great weekend. If you either sent me an email or have questions, now is the time to get those things addressed. Else, I'm just going to kind of keep working through the assignments. My intent was to kind of continue with section 1.6 with where I left off with my other class. We don't have to start there. We can start someplace else or work on other questions if you guys want. But if there aren't any requests, then I'm just going to pick a point and kind of start there. Um, I might do another pass. I might go through the quizzes as well. Uh, but yeah, we don't have to do like 1.6. I think so for exam two. This is the top of week 6. All right, so this is the top of week 6. Exam two, we can anticipate it in during week 8. I don't really want to talk about stuff after exam two just yet. I want to kind of save that for after. I want to just focus on things that are more so geared towards exam two for right now for this week and next week. So um, you know, might be a little bit kind of one of these things, but yeah. So I'm just gonna focus. I'm just gonna kind of pick up where I left off. We got people joining. Uh, but yeah, if you have questions or if you like want to see a question, if you want to you have any requests or anything of that nature, now is the best time to get those things addressed. This is really a study session. I'm just filling it with our homework. There was something else with exam two. Also, be ready. I intend to do a scheduling wizard. Like I think it's something where I can like create schedules and we can sign up for different time slots. So I'll figure that out and set that up in preparation for exam two. It'll probably take us some time because I have a lot of students, but so you can anticipate for exam two, hang on, for it to be similar to exam one um, with an oral component, all right? And so for the oral component, the main thing that I need on my end, I just need to be able to see your face. Um, so when you have your session, you can tell me what to write. I'll write it. I'll be showing my screen. And you can get a little creative with your presentation style, like because like right now, what I'm using like OBS, which is a online broadcasting system. It's free. I'm using my iPad and QuickTime. It's a little bit much for the system that I got set up, but it also doesn't hurt to figure something like this out because with this day and age, with everything going remote, and we're having to do more and more remote stuff. That's a skill set that it doesn't hurt to have. Be able to give virtual presentations. So, if you wanted to take the time to figure that out, I would notice it at least. Um, and again, I just feel like it's a good skill set to have. Anything where you're on the computer and you're figuring out things like that is really good to have in this time period. Yeah. So I do monitor the chat. I think I'm going to go ahead and suppress my audio right now. Again, if you have a request, if you have a question from the homework or any assignment or just anything from math related, now is a good time to get those requests or answers, those questions answered. If there aren't specific questions, I'm just going to kind of continue working through questions where I left off with my last group. So let's actually hop over. I want to hop over to Pearson, and so with that group, let me make sure I'm showing properly. I need another screen. Uh-oh. Okay, that looks good. That looks good. I don't know why it does that. Okay, so with that group, I left off with section 1.6. Exam 2, let me see. Student. Okay. What? Oh, that's interesting. Exam 2 is more so focused on sections 1.4, 1.5, and 1.6. But just keep in mind that like math by default is cumulative. For instance, I can't add stuff from 1.6 without referencing materials from like 1.4, 1.5, 1.3, 1.2, 1.1, right? So by default, math is cumulative. So even if whether I ask specific questions from 1.1 to 1.3 or not, it's kind of inherent in the way that math is designed. Those previous sections are kind of generally automatically there. Man, we just got people like popping in. Hang on. That's the only thing that's like slowing me down, but it's all good. Okay. So yeah, let's keep going. So where I left off with my last group was section 1.6. And my recommendation, if you haven't completed now, just as a reminder also, so I did load all the homework for the semester. I did load, let me see what's going on there. Let me check the chat real quick. Oh, in the waiting room. Okay, let me see. Okay. Do. MNOP. Yeah. And that's interesting. I keep wanting to say you guys' name, but I'm trying to not say you guys' name because I'm streaming. So just trying to keep your information sensitive. Yeah, just as a reminder, I do want to remind you that, yeah, let me just plug this thing in. I did load all the questions for the semester, right? So all the questions for the entire, so if you want to get ahead, honestly, you could finish all my assignments early, max out the credit or the score, and then just be waiting for the exams. And like, you know, the midterm is a little different and the final exam is a little different, but you can honestly get ahead. Like if you can, and the video lectures are loaded for the entire semester. We still got people coming in, so that's the delay. Okay. You know, so that would be my recommendation. So that way, because you know, when midterms hit, it's generally what happens. All your professors are going to be giving exams at that time. So that's why I went on and made things available up front because I could, and I know that like the scheduling is kind of based on you, right? So if you get ahead, then that way when midterms hit, you have less that you're trying to do all at the same time. And especially when the finals hit. Another thing is that the closer we get to, especially the final exam, Pearson starts to slow down because you have people all over the world using Pearson, and like a lot of, and especially in the States, people, the server gets overrun and it slows down and it becomes unreliable. So my recommend, you definitely want to just try to get ahead as best you can. Let me check the chat real quick. Yeah, so the midterm is just exam 2, right? That's going to be during week 8. Um, it's pretty much going to be the exact same as exam 1. I'm just going to incorporate an oral component that's going to be about 20% of your grade, right? I don't want it more than 20%. I think that's reasonable. Um, okay. You should be able to see this. So this is question number 11. It comes from section 1.6. I got my morning voice thing going on. I don't know. It just does that at times. It's like the vocal cords get relaxed, and I got this like Barry White, oh baby, baby, you know, kind of thing going on. So it is what it is. I just try to have fun with it and keep it moving. And I encourage you to do the same, like in the sense that whatever it is you have to do, try to find a way to have fun with it. Like it just helps with the energy. It helps you to get through it, and it makes the time go faster, whether you want the time to go fast or not. Sometimes, a lot of times, I'm having fun, but I want to slow down time, and that's a struggle. But to speed up time, you just raise your vibration. You try to get in a good mood. You try to have fun with it on some level, and then next thing you know, it's over. You're like, crap, that went too fast. So this is question number 11. It comes from section 1.6. This is question 29 from the back of the book. Now, and there's actually a lot of questions we can go back that aren't in the homework that we can actually kind of work on that you might see on your exam. So I might go back and do something like that. The functions f and g are given. Evaluate f compose g and find the domain of the composite function f compose g, right? So this circle thing, right? So a lot of times, I'm not sure if you watched that lecture or not. So I'm going to say it now. So this symbol, right? This is combination of functions. Section 1.6 is about combining functions. Give me a second. The same way that we can like add, subtract, multiply, and divide numbers, we can do something similar with functions. So a lot of times, so you know, with previous questions, we've kind of explored adding functions, subtracting functions, multiplying functions, and dividing functions. So this symbol is called compositional functions. Students often think that this symbol means multiplication. This does not mean multiplication. So I'm just reiterating it in case, you know, because I know I have a lot of ears. I'm trying to get everybody on the same page. This does not mean multiplication. This means the second function inside the first function. So it's like a function within the function. So this is called f compose g, compositional functions, right? So we have this function f. Let me take some notes really quickly. Let me go to paper. I like grid paper. Okay. Let's see. So this is question number 11. Cool. Looks like it's behaving properly. This comes from section 1.6, question 29. It says evaluate. Okay, it says find, evaluate f compose g and find the domain. All right. So I'm going to say find f compose g. So that's the open circle. And find the domain. Just taking some notes before we hop over instead of screenshotting. F of x is the square root of x minus 7, and g of x is 2 minus 3x. Okay, let's hop over to the tablet. Make sure, okay, looks good. Okay, so these are the notes I just took from that question. All right, we want to find f compose g, and we have these two functions, right? Okay, so again, we're asked to find f compose g. All right, what does this mean? Let me make this. This means f of basically the second function. I'm going to do g in green. So the second function inside the first function. All right, so f compose g. Also, as a friendly reminder, we get unlimited attempts on all assignments on Pearson. So anything that's on Pearson, I went on and set it to unlimited attempts, and there's only a 10% late penalty. So every week, even though each assignment is due on a weekly basis at Monday morning at 9 a.m., you can work on any assignment past the due date with only a 10% late penalty. So if you want an A minus on any assignment, you just keep working on it until you get that score, right? And I did that intentionally because the repetition is how you learn, right? Whatever we do the longest, we do the strongest. Whatever we practice, we get really, really good at, right? If we practice complaining, we get good at complaining. But if we practice, determination, we get good at being determined. Whatever you practice, you get really, really good at. Okay. So f compose g means the second function inside the first, right? We're going to do g of x. I'm just going to do that in green to help it pop, right? So then this means f of, now what's g of x? G of x is 2 minus 3x, right? So all we're going to do, we're going to just, all this means is we take the function f, we write it like normal, but we replace all the x's with the green thing, right? So the next part is, so f is going to be the square root of x. I'm replacing x with a blank parentheses, minus 7. And then what color goes into the blank parentheses? Green in this case, 2 minus 3x, right? So all we did was replace each x with the function g, right? So then we want to simplify, combine like terms, do any distributing. I don't think there are some like terms. There's no distributing going on the way we have it written. So this gives us 2 minus 3x minus 7, right? I was able to just lose the parentheses, associative property of addition and subtraction, right? Or associative property of addition. And then we combine like terms. 2 minus 7. 2 minus 7 is what? Negative 5. So then this is going to be the square root, basically negative 3x minus 5, right? Okay, so that's the simplified function. So then the other part of the question asks us to find the domain of this composition, right? So when we're finding the domain of a composition, I'll do this in purple. There's a 3-step process that I recommend. I'm going to say domain of composition. There's a 3-step process that I recommend. The first step, step number 1, we want to find the domain of the inside function. Here, let's see. Let's start like this. Find the domain. I don't want to write all that. But basically, the first step is find the domain of the inside function. Find the domain of the inside function. Secondly, you want to find the domain of the simplified function. And then third, we want to take their intersection. Another reminder. So all these things that you see me writing throughout the semester, I made a PDF copy of anything that you see me writing. Is available on our Blackboard page, right? Our Blackboard page is a central hub for all of this information. So anything that you want to find, you just go to our Blackboard page and it's there. The link to the homework on Pearson starts in Blackboard. All these PDFs with the documents that you see me writing, it's in Blackboard. My YouTube channel links to the playlist for these recordings that starts in Blackboard. So anything for our class that you need, let me make sure I get this guy. Oh, okay. I always forget that they're brothers. And like if one shows up and the other doesn't, it might be bad news. But they're usually both here together. They seem like they're being each other's keeper. They're being accountable for each other. Anyway, it's all good. Um, but yeah, anything that you're looking for with our class, I always try to link it to our Blackboard page, and it's about 7 or 8 folders, and I try to label them, make appropriate labels or whatever. Okay, so now let's see this process of finding a domain. Let's see it in action. Okay, so first let's find the domain of the inside function. So our inside function here is this g of x, where we have this 2 minus 3x, right? So this g of x is in the form of y equals mx plus b. You have to do some manipulating and you have to kind of rearrange some things, but you should be able to see that this is a linear function, right? Y equals mx plus b. So given the hint that you have to rearrange some things, take a moment and can you identify the slope? Can you identify the y-intercept or the b, right? So if we're looking at g, the slope should be, hopefully you're thinking -3, and the y-intercept should be 2. Okay, do we have brothers in the chat? I want to kind of play a quick little game. Are you guys in the chat? It's an algebra game. Anybody listening in the chat? Let me see. Can I get any takers? You guys in the chat? Okay. I'm going to let it go then until I get a response. Okay. Because it's like a call and response. Okay. So, all right. So let's focus on the domain of the inside. So with that being a line, all that is a diagonal line with a negative slope with the y-intercept is 2, right? So the slope was -3, the y-intercept was 2. So we started 2. We go down 3 and right 1, and then we put a second point. We're going to have a diagonal line with a negative slope, right? So if it's a diagonal line with a negative slope, the domain of that, the very left to the very right, is going to be all reals, right? Yeah. So again, the first step, the domain of the inside function. So in this case, we'll do it like this. The domain of g of x. I'm going to shorten it like this, is all reals. This is my symbol for all reals, and I'll label it as, let's see, all reals. And let's do like this. Man, I really like writing on this iPad. It's just fun because you can do stuff like what I'm doing right now. I just enjoy it, and I'm actually an artist. I do all sorts of arts. I draw, I sculpt, I paint. I actually do martial arts. I'm actually a musician. I'm a Renaissance man, but it's weird because I can't. I don't know. It's just weird. But I actually do all of this stuff. I play the piano, like a lot of different things. Anyway, so because I'm an artist, that's why I enjoy writing on this because I know how to make things like kind of look a little bit pretty, but I don't do. I mean, and I actually do photography. I'm getting into a whole bunch of stuff. I haven't monetized it yet. I will at some point, but I just be doing it because it's fun and I can't help it. I do origami, all sorts of crap. I want to get into like 3D printing because the applications. Oh my god, it's like anything. Like okay, for instance, this is actually the guy that told me this. He said the phone companies made him stop because he was taking too much money from them. But he said he got a 3D printer and he was making his own phone cases. I was like, oh, that's genius because I be having ideas for phone cases and it's never made. And I was like, I don't have a way to make it. But I be having ideas of like the perfect phone case for like at least for myself because I know what I need. And so he was like, yeah, he had a 3D printer. He was making his own cases, and then the companies were like, hey, can you stop that? Like they made him stop. But yeah, this is wild. Anyway, I'm telling you, I have a crap ton of ideas, and it's like once I get like to a point where I'm not worried about like living, like on a day to day, man, I'm gonna be making like all sorts. I'm gonna make a Wakanda for real. I promise you. Like I be having so many ideas, it just don't stop. Anyway, So the domain of the inside function is all reals. It's just it's a diagonal line. So that domain is all reals, right? So that's the domain of the inside function, going on tangents. Secondly, we want to find the domain. Yeah, no, I got a bad connection. Can't do anything about it. We want to find the domain of the simplified function. Hopefully my handwriting isn't too bad. And by all reals in the previous part, that just means negative infinity to infinity. That's the domain there, right? So the simplified function, and let me do like this. I could do that's fine. That's fine. Actually, yeah, that's fine. So the simplified function is this square root of negative 3x minus 5, right? So we'll say the domain of square root of negative 3x minus 5, right? So with the even radical with something like square root, we can't take the square root of negative numbers, right? So that radicand, that part inside the square root, that has to be greater than or equal to 0, right? We can't take the square root of negative numbers, so the radicand has to be non-negative. Does anybody know the difference between positive versus non-negative? You know, I know I got people, anybody know the difference between positive versus non-negative? I'm going to leave that open. So again, for even radicals like square root, fourth root, sixth root, we can't take the even root of negative numbers. So in other words, this negative 3x minus 5 needs to be greater than or equal to 0, right? Because we can't take the even root of negative numbers. So now if we solve this inequality, add the 5 and divide. I guess I need to write it out. I wasn't going to, but. So if we add 5 to both sides, let's do like this, plus 5 and plus 5, okay. We get the inequality comes down. On the right-hand side, we have 5. A number plus its opposite as is 0, and the negative 3x comes down, right? So then something else happens that you have to kind of watch out for, right? So if we say you have a negative 3 times x, and we want to use the inverse operation, what's the inverse operation of multiplication? Inverse operation of multiplication is division. We would divide both sides by negative 3, and something happens here. Hopefully you're aware of what's happening. When you divide, on the right-hand side, we have negative 5 by 3. If we multiply or divide the inequality by a negative, are you aware of what happens? It flips. Flips, right? Because we multiplied or divided by a negative, so the inequality flips. Let's see. So then the domain of the simplified function is that x has to be less than or equal to negative 5/3, right? So then the far left, if we write that in interval notation, the far left is going to be negative infinity. Let me see something. The far left is going to be negative infinity. The far right is going to be a negative 5/3. Infinity always gets a parentheses. In this case, because of the bar, because there's a bar, let me color green. No, yeah, I'll just do it like this. Because there's a bar, it needs to be a square bracket. Okay. So for the first part, we got the domain was all reals. The second part, we got negative infinity to negative 5/3, and then the third step, we need to take the intersection of those two results. Let me shrink this down. I just want to fit it in this space here. Trying to think how can I be a little bit more economical, but I guess that's fine, right? Okay. So for the first part, we got all reals. The second part, we got this. So then the third step, we need to take their intersection, right? So the intersection of these sets is basically, you want to take the results that they have in common. Like whatever they have in common, that's what we want to take. All right. So if we take all reals, is this, and we intersect it with this half interval from negative infinity to negative 5/3, the intersection of everything with this half interval is going to be just the half interval, right? Let me copy, paste, shrink it down, rearrange, right? So everything intersect the half interval is going to be the half interval. So so the final result is for the domain is going to be this guy. All right, that's been the best explanation I've come across for explaining the domain of a composite function. It's a little bit involved, and some of them do get a little bit funky, but this is what I've come across. It seems like it works most. I haven't seen where this has not worked. Let's see. I think he got attendance already. Okay. Oh, let him in. Okay. Let me check the chat. Okay, let me check the chat real quick. The bar versus, this is a great question. So a question came up, says when do you use the bar versus when do you use the parentheses? Okay. The brackets. Okay. So the brackets, for instance, the difference between the parentheses, for instance, that this red bracket that we have over here, we use that because there's a bar under the equal sign here, right? That bar means we can be equal to that number. So the difference between a square bracket versus a parentheses, like for instance, if we had a parentheses, let me just show this as an alternative. If that would be parentheses if this bar were not there, right? So if that bar was gone, it would be a parentheses. Parentheses means we get really, really close to that number, but we don't actually reach that number. Like you get infinitesimally close coming from one side or the other, but you don't actually reach that number. But in this case, because we have the bar, that's why we have a square bracket. All right, hopefully that cleared that up or put it in context, right? But yeah, the brackets mean, so parentheses mean we get really, really close to that number, but we don't include that number. Brackets means we get really, really close to that number, and we do include that number. All right, that's the difference between those. So this is a discussion about closeness and then exactness. Parentheses, you get really, really close, but you don't actually reach it. Brackets means you get really, really close, and you actually do reach it. You actually do include that number, right? Okay, so that's what those symbols mean. All right, and a lot of times in math, a lot of stuff comes to that point. Like, okay, are we talking about close to this number? Can we actually include this number specifically? Like, it's the difference between 5 and 5.00000001, right? The 5.0001 is really close to 5, but there are cases where the 001 will work, but the 5 won't, right? Sometimes a really close number will work and the number itself won't, right? So that's what this whole discussion is about, that very subtle concept. So these are the results that we got. We got the simplified, we got the composition was the square root of negative 3x minus 5. And the domain, after we found the domain of the inside function, we found the domain of the simplified function, and we took their intersection. We got this interval that you see in the bottom right-hand corner of the screen. So let's hop back over to Pearson. Hopefully Pearson is still up and running, because sometimes when you're way too long, it does kind of shut down. But we can still put our result in. So we got the square root, negative 3x minus 5. I'm just going to hit enter. Simplify your answer type using radicals. This looks good. Okay. And then the domain. Okay, so we got parentheses, negative infinity to negative 5 over 3. And on the right-hand side, we got a square bracket. And if you use the wrong grouping symbols on Pearson, it's going to mark it wrong because it is wrong. So not only do you have to get like the intervals right, but you also have to get the grouping symbols. I know the grouping symbols are very subtle and it's very easy to miss it, but if you don't use the right grouping symbols, it is wrong. But that's why I give the unlimited attempts, and you have a little bit of wiggle room. You just need to take advantage of it before it's too late. Okay, that was fun. I was just filling it in because we don't have to rush. So let's try the next one. We have these two functions. Find each composite function and describe the domain of the resulting function. I don't even know if we have time for this one. This one might take us to the end of class. So let me take some notes here. Let's take some notes. All right. And then, I mean, I could go a little bit faster, but we don't have to, so there's no need to do all that. Okay. So this is question number 12. This comes from section 1.6, question 33. We're given that f of x equals 7 minus 5x, g of x equals 8 plus x squared. Find each composite function and their domain. Okay, find each composite function and their domain. Okay. So then for part A, we have F compose G. Okay. Part B, we have G compose F. I think we mentioned something about the order being important. C is F compose F. And D is G compose G. Okay. All right, let's hop over to the tablet and see the notes that we took. Let me check there. That looks good. Okay. So let's start with part A. Part A asks us to do F compose G, right? So what's fuchsia? It's like pink. I'm gonna leave F in black for right now. So let me see. We have f of x equals 7 minus 5x. I'm going to do g in green again. G of x is 8 plus x squared. Okay. So now, if we're going to do f compose g, again, this means the following. All right. This means what? The second function inside the first function, right? So g inside of f. So what that means, we're just going to write f of x like normal, and we're going to replace each x with the green thing. So f of x, we got what? 7 minus 5x. So this is going to be 7 minus 5. First thing I do is replace the x, each x with a blank set of parentheses. And then what color goes into the blank parentheses? The green. Okay. So then at this point, we can just simplify. Now notice, we have this negative 5 in front of the parentheses. So we need to distribute that negative 5. That's multiplication over addition. All right, so if we distribute that, we get the following. We get 7. 5 times 8 is what? Negative 40 minus 5x squared. Okay. I think we can still combine like terms. I'm going to write it like this. We get negative 5x squared. What's that difference? 33? Negative 33? I think this is a simplified function that we get. Okay. Okay. So that's That's our composite. Then the three-step process for the domain. So first, we want to find the domain of the inside function. All right, what's the domain of the inside function? The inside function is going to be g, so we'll say the domain of g of x. Let's see, g is a parabola. The highest exponent is a 2, right? So this is x squared, and we added an 8 on the outside of our basic function, right? So if we think about, you can actually put this, yeah, let me pull that up. I was avoiding it, but yeah, let me pull it up for you guys. So you can see, now hopefully you have, well, because we're remote, I mean, I feel like it's not a bad investment. Let me see, does it, let's do like this. I don't know if you have a Texas Instrument graphing calculator. Even if you don't, because we're remote, for most of our things, you can like use like a GeoGebra or Desmos for graphing. Let me see if it'll show up here. Okay, so I need to do like this so you can see it. So let's say that you're working on a graphing calculator like this. All right, let me minimize this. That's fine. Say you're working on a graphing calculator and you want to see it right now. The function g in green, it should just be a u-shaped graph that we moved up by 8 units if we consider transformation. All it is a u that we move up 8, and that's it, right? So let's go to y equals in the upper left hand corner, and I'm going to type g is just like I see it, 8 plus x squared, right? I could change the window, but if I just do a standard zoom where I went to zoom, I'm gonna hit number 6. That just puts 10 in all direction. And notice we have a U-shaped graph that's been moved up 8 units, right? Yeah, so I just wanted you to see that. And it's fine. All right, so now, if we have a U-shaped graph that's been moved up 8 units, what's the domain of that, right? The domain of that is the very left to the very right, and you got to keep in mind that this extends beyond what that window was showing. You know, we can't see the whole thing, but you know, you have to use your imagination and be aware that it continues the pattern forever in each direction. So if it continues the pattern going to the left and to the right, then every x is going to be accounted for. So the domain of a parabola or a polynomial is going to be all reals. Let me bring my thing back. So the domain of g is going to, you can do all reals is basically negative infinity to infinity. All reals, right? So that's the domain of the inside function. Secondly, we need to find the domain of the simplified function. All right. Let me see the time. Maybe I can do that during the exam too. Because I intended to ask each of you, like, what are your majors? What are your goals? What do you enjoy doing? So I can just have some context. I'm not going to be able to finish this one because we're almost out of time. But I can at least finish this part A, and I'll just pick this up with my next class. The simplified function is that negative 5x squared minus 33. That's a parabola. It's stretched vertically by a factor of 5. It's turned upside down and is moved down by 3. That's just using transformations, right? If we consider the transformations, first, the basic form is a parabola, which is the x squared. There's nothing inside the squared part. Let me see something. I don't know. Got somebody popping in. I can't give attendance credit for this because we're about to leave. All right. I'll be lax with them for today. I'll let them have it. I'm not gonna be like that today. Okay. Let's see. So yeah, the transformations here. Basic function is x squared. Then whenever I'm doing my transformation, multiple transformations, I work my way from the inside to the out. So the next item was this 5. That says to stretch vertically by, because it's on the outside, we multiply the outside by a number larger than 1. That means we stretch it vertically by a factor of 5. So the x values stay the same, but all the y's get multiplied by 5. Then next is this negative here, and because it's outside our basic function, it means we flip it top to bottom, right? So now we got a tall and skinny U-shaped graph that's upside down now, and then the final thing is we move it down 33 units, right? So the domain of that I think is also all rails. So we got lucky. So let's write it here. That was G, so we'll say the domain of the simplified. I don't even know what letter that is. Simplified function. In this case, it just happens to be all rails. All right, so we got lucky there. And then in the third step, we want to take their intersection. Okay, take their intersection. All rails intersect all rails, so I'll write it like this. All rails intersection, all rails gives us all rails. All right, so we kind of got lucky with this one. That it was simple. Let me go check it on Pearson. Let me see if I can at least get through these two components. Let's hop over here. Let me make sure it's showing. Looks good. Okay. So the simplified function that we got for this part, we got negative 5x squared minus 33, negative 5x squared minus 33. And then the domain in interval notation, all rows. So we're going to say negative infinity to positive infinity. Okay. Enter. All right. So let me see. That is close enough. I usually let you guys out at like the 45-minute mark. I'm not going to have time to finish this question. I mean, honestly, I probably could, but I'm going to just save it for my next class. That'll be fine. If there aren't any burning questions, if you made it into my Zoom, I went on and gave everybody attendance credit today. I know we had some stragglers kind of towards the end. It's okay. Don't make that a habit though, because if I see people coming in at the last minute like that, I'm gonna be like, okay, I'm just gonna be like, okay, you know what? You're past the 15-minute mark. I'm gonna stop giving credit for that, and it can mess up your money. The best thing is just be here when class starts, so that way you're not dealing with any of that stuff. Yeah, I can't think of any other announcements. If you guys don't have any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Until Wednesday, take care. Peace.